Okay, for example 3, we're going to continue same method. We are going to move everything to one side and set our inequality to 0, and then we're going to solve that related equation. So I can take out a common factor of x, and then it leaves me with something that I can factor, which is the difference of squares. And so then we have x plus 1 times x minus 1 when we factor. And then I'm going to take each separate factor and set each factor equal to 0 and solve. And so I have 3 critical numbers that I'm going to put on my number line. I'm going to put them in order. So we have -1, 0, and 1. I know I'm going to have open circles at those endpoints because of my inequality symbol. And then I just need to test a value in each region. I'm going to write my factored form and then put back that inequality symbol in, and that's what I'll be testing in. So let's go ahead and try -2. And I already know that each one of these intervals that I'm testing is going to wind up with 3 factors. So I'm going to write a little assembly line right here. When I put a -2 in for x, I get negative. -2 plus 1 is negative. And -2 minus 1 is negative. So the overall result of multiplying 3 negatives in a row is negative. And a negative is not greater than 0, so this is a false region or interval. Then I'm going to substitute something in here. We're going to end up having to put in a -1/2, but that's okay. It's not as bad as you think. Plugging in a -1/2 for x makes this factor negative. Plugging in a -1/2 here makes the second factor positive, and plugging a -1/2 in the last factor makes that negative. And the overall result would be positive. And so this next section is true. A positive number is greater than 0. And then I'm going to plug in a 1/2. And once again, it's really not that bad plugging in that fraction. When you plug in a positive 1/2 into x, that term is positive. When you plug a 1/2 in for the second factor, you get 1.5, and that's positive. And when you plug a 1/2 in for this last x, you get -0.5 as your overall answer. And a positive times a positive times a negative is a negative. And a negative is not greater than 0. So this is false region in here. Okay, then finally in the last section, let's go ahead and plug in a 2, and I get positive, 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 and my overall result is going to be positive, and that's true over here in the last section. So that interval didn't work, that interval didn't work, this worked in between, and this worked in between right here, or at the end I should say. This worked on the end. And so our final answer is going to go from -1 to 0, not including the endpoints, unioned with 1 to infinity. And then let's go ahead and do example 4. Now what makes example 4 not so nice is that it is not factorable by grouping or any easy method. So we're going to have to use P over Q. So let's move everything to one side. I'm going to add that x squared over, and I'm going to add that 3 over. So I probably would check out to see if I can factor by grouping, and you can't. When you take out your GCF here of x squared and you try to make a match, it's not going to work. So there's no factor by grouping. So we're going to have to go ahead and do some synthetic division for P over Q, but that's okay because when you go ahead and build your list for P over Q, it's factors of 3 over 1 and you only end up with plus or minus 1 and plus or minus 3. So the list isn't that long. And even better yet, not only is the list not long, but I think 1 works. So when we do our synthetic division, we only have to do it 1 time, and the rest will be easily factorable. So I'm going to go to and quickly factor this, or divide this, I should say, and I get a remainder of 0. So the first factor that comes out is not going to be x plus 1, it's going to be x minus 1. The 0 is 1 in the box, but the actual factor that it comes from is x minus 1. And then we're left with x squared plus 2x minus 3. And then that's going to be easily factorable now. And I don't think any of the homework problems require synthetic division or P over Q. I do think they all factor. There might be one that has 4 terms, but you can factor by grouping. So that's going to be positive and that's going to be negative. So let's go ahead and draw in our number line and put our critical numbers in. One of the factors repeats, so we only have 2 critical numbers, negative 3 and 1. And we have closed circle because of our symbol is greater than or equal to. And I'm going to go ahead and write my factored form on top. I'm going to put the 2 minus 1s, x minus 1s next door to each other. And put the x plus 3 last. And then our symbol of greater than or equal to back in. And then I'm going to substitute in a negative 4 first. And for each interval, we have 3 factors that we need to multiply together. Okay, so we get negative, negative, and negative. And the overall result is going to be negative. And a negative is not greater than or equal to 0, so this is false. Okay, well, let's go ahead and plug in a 0, and you get negative, negative, and positive. The overall result right here is positive, and a positive number is greater than or equal to 0. And then finally on the end here, let's go ahead and put in a 2, and you get positive, and you get positive. And the overall result is positive, and you get another true. So we actually get to shade right past over that 1, right through it, all the way to infinity. And your answer goes from negative and 3, including with a bracket, all the way up into infinity.